All right, everyone. In this video, we are going to begin a discussion over the next few videos of everyone's favorite numbers to work with, fractions. Now, as far as fractions go, I think multiplying fractions tends to be the least objectionable thing we do with them. When we multiply two fractions, we simply go straight across the top, straight across the bottom. No common denominator, no reciprocals, nothing like that. We just multiply across the top and the bottom. So here we have 2 times 3. So my numerator, which is what we call the top of the fraction, is 6. So let me write that down in case you did not know that this is the numerator of the fraction. And the bottom of a fraction we call the denominator. Just to get your terminology, particularly when we add and subtract fractions, going to use the word denominator an awful lot. So in our denominator, we have 5 times 7, and that is 35, and we are done with that problem. The second example I have for you, I incorporated two things. First, I have a positive times a negative. So if you are unfamiliar with the rules for multiplying signed numbers, go up a couple modules to the multiplying integers module and brush up on that. So a positive times a negative is going to give me a negative result. Now in this pair of fractions, I have some factors that I can reduce. So I personally like to reduce first because I like to have the smallest numbers possible to work with. So I notice that I have a 15 and a 25. They both share a factor of 5. 5 goes into 15 3 times. 5 goes into 25 5 times. I notice 8 and 6 share a factor of 2, so 2 goes into 6 3 times, 2 goes into 8 4 times. I do not see any other factors in common to any of the numbers that I have left over, so I will now multiply. My numerators are now 4 times 5, that is 20, and my denominators are 3 times 3, which is 9. So those are my examples. I'm going to flip the slide forward, and I have 3 problems for you to do. Why don't you go ahead and pause the screen right now, take a look at trying these 3 multiplication problems, and then hit play again. All right, I'm back. Let's go ahead and multiply. So my first problem, 4 over 11 times 2 over 9. I do not have any factors in common to the numerator or the denominator, so I'm just going to go ahead and multiply. So when I multiply my tops, 4 times 2 gives me 8. When I multiply my bottoms, 11 times 9 gives me 99. Done. 8 over 99. Nothing else to do there. My second problem, I've got 2 negatives, a negative right here and a negative right there. Again, from the rules for signed arithmetic, multiplying 2 negatives gives you a positive. And as I'm hoping you know, we don't write a plus sign unless we are dealing with polynomials. So I'm just going to go ahead and reduce. And the only thing that reduces on this problem is I notice 7 goes into 14 2 times, and 7 goes into 21 3 times. Nothing else is common to the numerator or denominator. Please do not reduce the 3 and the 9. Those are both in the numerator. So actually you are now going to multiply the 3 and the 9, and you are going to get 27. In the bottom, in the denominator, I've got 2 times 5. That's going to give me a result of 10. Students ask me, should I make this into a mixed number? And my answer is generally no. Mixed numbers are not usually super helpful in algebra. They tend to create more problems when you have to do operations with them. So I would say leave your answer as a reduced fraction. Okay, this is what's called an improper fraction. Okay, improper does not mean wrong. Improper just means that the numerator is larger than the denominator. My last problem that I asked you to do, I have a negative fraction times a positive, so my answer is going to be negative. I do have a little bit of reducing I can do. 7 goes into 7 1 time. 7 goes into 35 5 times. 2 goes into 8 4 times, and 2 goes into 10 5 times. I don't see anything else, so I'm ready to rumble. My numerator is 1 times 4 is 4, and then 5 times 5 is 25, and we are done. So that's review of multiplying fractions. There's some practice right below this. Brush up. That way you can be confident when you do your algebra.